no other x squareds. Negative 3x plus 6x is 3x. Negative 28 plus negative 3 is negative 31. And you're done. And then h times p of x, same two functions. Now we just distribute x squared times each term, negative 3x times each term, negative 28 by each term, and you get this. Combine like terms and you get 6x cubed minus 21x squared minus 153x and then plus 84. For L, find the domain. Like the earlier problems, anytime you have a fraction, just set the denominator, in this case h of x, equal to 0. Factor, h of x factors to x minus 7, x plus 4. So your two zeros are x equals 7 and x equals negative 4, which means that x cannot equal those values since it's in your denominator. So your domain is all real numbers except 7 and negative 4. Number 5, f of g of x. So take g of x, which is x minus 7 over 2, plug that in for x into the function f of x. 2 times x minus 7 over 2 plus 7. Here you could distribute the 2, or you could just cancel out the 2's. That would be the quicker way, and you would get x minus 7 plus 7, which is just x. G of f of x, 2x plus 7 replaces x, so instead of x minus 7 over 2, it's now 2x plus 7 minus 7 over 2, plus 7 minus 7, cancel, 2x over 2, 2's cancel, and you're left with x. So since each of these functions, g of f of x and f of g of x, both simplify to x, that means they are inverses. Number 6, you had to evaluate f of 9. So you just first realize that 9 is greater than negative 4. So you plug that into the second part of that function, 4 thirds times 9 minus 5, and you get 7. F of negative 7 is less than negative 4, so it gets plugged into the first part of the function. So 2 times negative 7 plus 1, and you get negative 13. The third part, graphing f of x, you're not going to have to graph piecewise functions on the final exam, so I'm just going to skip that for time's sake. The answer is on the answer key if you want to take a look at that problem. If you have a question, we can go over it in class, but not going to be on the final. Number 7, it says, given those polynomials which are already factored, list the zeros and multiplicity. So you already have it factored. The factors are negative 9x, x minus 5, and 3x plus 5 squared for 7a. So you just set those factors equal to 0, you get x equals 0, x equals 5, and then when you solve this one, you get x equals negative 5 thirds, but since it's squared, that means it's multiplicity 2. Meaning you have that 0 and it touches, that's where it touches the x-axis and does not cross. And then 7b, 3 factors, x plus 3, x minus 2, x minus 5. 2 of them are squared, so that just means it'll be multiplicity 2 for those zeros. And you have x equals negative 3, x equals positive 2, x equals positive 5. Negative 3 and positive 5 have multiplicity 2. So the graph would touch the x-axis at those values, but not cross.
If I can have your attention, please. If you are going on the front floor, please be up in the lobby now. If you are going on the front floor, please go to the lobby now.
Pardon the interruption. Keep on moving. 8a. For 8a, it says what the maximum number of zeros. The maximum number of zeros is equal to the degree, and since this polynomial is of degree 4, there are 4 maximum zeros. For b, the maximum number of turning points that g of x could have. The maximum number of turning points is the degree minus 1. Since the degree is 4, there could be 3 turning points. For c, the possible or potential rational zeros, that's where you take the factors of the constant, the factors of the leading coefficient, and divide. So your possibilities are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. For D, asking if x minus 3 is a factor, easiest way is to use synthetic division. X minus 3.
Please, the climate committee /grit meeting will be on room 206. Again, that's the climate committee /grit meeting will be on room 206 at the time.
Again, sorry about that. Trying to do this while at the high school is rather difficult. But moving along, x minus 3 is the factor, which makes positive 3 the 0. So we put 3 on the outside. Coefficients for the polynomial are 1, 4, 2, -1, and 6. Using synthetic division, you can see that your remainder is not 0, which means x minus 3 is not a factor. For part E, asking you to write g of x fully factored.